Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Dr. Elena Hyde, and I'm joined tonight by Julie Tomei. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. As a reminder, this broadcast is a little bit different than our regular York Universe because we're not on astronomy.fm directly tonight, but York Universe will continue to broadcast every Monday night at 9 p.m. local Toronto time or Tuesday morning at about 2 a.m. UT, either here directly on YouTube or over back at astronomy.fm once they're able to pick us up again. The York Universe production works in concert with our online public viewing, that's OPV, and it's run by our amazing observatory team, running at the very same time, 9 to 10 p.m. local Toronto time. And of course, if you're listening to this live, you probably already know, but just in case you're catching a recording, you can always find us by going to yorku.ca/science/observatory and following the links to OPV for online public viewing to join the chat. Our broadcast is, as always, powered by and in partnership with astronomy.fm, the voice of astronomy. And if you have any questions or comments or ideas for future topics, please send us an email at observe@yorku.ca. You can always find us on Twitter with at York Universe or at York Observatory, and on Instagram with York U Observatory and Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to join in the fundraiser and make a donation, you can see our website at that same site before, yorku.ca/science/observatory. There's also some fun links to observatory swag, new calendars for 2024 coming soon. We will be monitoring the chat room over on YouTube for questions, and our crew will be there to take your questions and post content. The current weather is a little bit piecemeal. Not quite sure if it's going to clear tonight. How is it where you are, Julie?
That's a good question. That would have required me to look up when I was outside.
This is what we always say. Don't forget to look uppity. You never know what could be up there. They could find starlinks, maybe a meteor. If we get a really big sunspot, maybe even some northern lights.
Yeah, I'm usually pretty good at doing that. I guess I was just a little distracted this evening when I went to pick up my daughter from work. So I don't know, but I'm not that far from the observatory, so I imagine it's probably much the same.
Yeah, a little bit piecemeal in the skies at the moment. It's been very hit and miss with Toronto weather. I guess Toronto is known for being very variable, but it seems that it's more so this summer than we're used to. Of course,
been pretty cloudy. It was pretty cloudy most of the day, so.
well, and cold this morning and then really hot this afternoon. You just never know what you're going to get. I will just mention that if people are interested in catching some interesting objects in the sky, there is always, of course, some fun planets out. So we've had a pretty good showing with Saturn and Jupiter and the moon the last couple weeks or so. And Saturn and Jupiter are still fairly nice to look at. So if you see something bright in the sky, well, nowish, it's probably Saturn. If you wait a couple hours, it'll be Jupiter coming up. So there's some really great things to see for sure if you can get the breaks in the cloud, which unfortunately there's no guarantee for where we are.
Yeah.
But if you want to get above the clouds now that you will avoid that problem. So we have a bunch of This Week in Space and Astronomy history planned, and I think all of them are above the clouds, if I'm not missing my guess.
I think so.
Do you want to get us started with one of our very own famous Canadian astronauts?
Yes, absolutely. So we are going back to September 9th, 2006, and the launch of STS-115. This was a mission to the International Space Station flown by Space Shuttle Atlantis. was the first assembly mission to the ISS post Columbia disaster, following the two return to flight missions, which were STS-114 and STS-121. The mission delivered the second portside truss segments. For those who keep track of such things, they were P3 and P4, and a pair of solar arrays, 2A and 4A, and some batteries. There were 3 spacewalks performed, during which the crew connected the systems on the installed trusses and prepared them for deployment, and did some other maintenance work on the station. The crew included Canadian astronaut Steve McLean on his second and last space flight. McLean became the first Canadian astronaut to operate Canadarm2 and its mobile base in space, as he handed the new set of solar arrays to American astronauts Ferguson and Burbank, who were controlling the original Canadarm. He also performed a spacewalk, thus becoming the second Canadian after Chris Hadfield to do so. The York connection to this mission, other than Steve McLean himself being an alum of York University, is that the mission patch that was worn on the clothing used by the astronauts was designed by Graham Huber, Peter Hui, and Gigi Lui, who were 3 students at York University at the time. And they also designed Steve McLean's personal patch for this mission.
Very nice.
Yeah.
Lots of great York connections there too. And I think it's especially pretty awesome because, as you say, he was at York University and he was actually a physicist. So he did the physics program at York, which a lot of our volunteers and Work City students are currently undertaking. So you're only 1 degree of separation away from space yourself if you've done physics at York.
Yes. I remember being in the office of the chair one day, and he happened to be in there talking to the admin assistant.
Oh my, when was this?
Early 2000s, maybe late 90s, because I was there from 98 to 2003. So around 2000-ish.
I wonder if this was before or after the big picture of him came up to the on the wall.
I don't know.
We
was
have
probably
that picture,
on campus to do a talk or something.
Oh, I'm sure. Yeah.
To say hello or whatever.
Well, it's funny because we actually don't have any of his STS spelling STS-115 patches, but we do have a couple STS-52 patches. And I know we were talking just before broadcast were they both designed by York students, and which one has the better artwork? They're both very nice patches. So
yes, they are. I like when art meets space.
Yeah, and it's actually artistic design for space is a whole different kind of space art intersection, because of course you have renditions of things that we can't get good pictures of, like exoplanets and accretion disks and things like that, but also just practical mission patches and stuff like that. So yeah, art is great. more art space crossovers, please. All right, so I'll keep us going in the space theme. I love this idea of crafts at launch, but I'm going to pick one for my next This Week in Space and Astronomy History, one that went to Mars because I found one. So September 9th, 1975, Viking 2 was launched. And this launch was using a Titan Centaur launch vehicle, and it went on a 333-day cruise to Mars. This is a long cruise, and this is not one that you would want to do with any humans on board, because the amount of food and water you would have to give them would be prohibitive for any kind of launching. It would just be a tremendous amount of weight. But this was an uncrewed craft, so it was fine. So Viking 2, 1975, you have to remember at this time, our knowledge of Mars was still not great. We really didn't know a lot about what was going to be there. And Viking 2 orbiter started returning global images of Mars even before it got into orbit. So Viking 2 was part of the U.S. Viking program to Mars, and it had an orbiter and a lander. So it was kind of the same as Viking 1, but you know, getting more data, and of course, touching down in a different area. So it was launched on September 9th. It took 333 days to get there, and that's because these orbits don't generally follow a straight path. They'll have a Hohmann transfer, and they'll go around to build up speed to try to, increase our fuel efficiency, basically. So the orbiter went into Mars orbit on August 7th, 1976. So this is, almost a year later, so over a year later. Um, and this was a pretty interesting mission because, of course, it starts sending pictures back, and the lander separated from the orbiter. So you actually kind of got a 2-for-1. You had a little lander coming down and the orbiter staying up. So the lander went to Utopia Planitia, which is a really interesting part of Mars. It's actually a low impact basin, and it's the largest recognized impact basin. I believe it's still the largest recognized impact basin in the solar system. Somebody online will have to correct me if I'm wrong now, but I think it is still technically the largest recognizable impact basin. And because it's so low, it's a very interesting point of Mars because it actually does get sort of Mount Everest temperatures and air pressures in the bottom at some times of year, which makes it a very interesting place for all kinds of Mars reasons. So Utopia Planitia was where it landed, and of course, this mission had a lot of things going on. So the orbiter primary mission was extended until, I believe, December 1976, and it had a close approach to Deimos, one of Mars's moons. So Mars has two sort of rocky asteroid-like moons at Deimos and Phobos, and they're sort of irregularly shaped because of their low mass. The lander was pretty cool in that it actually had a sort of an arrow shell that it was separating from. So we've seen more recent landings on Mars that had a sort of a controlled descent. This was not that. So this had an arrow shell with a heat shield, sort of slowing the craft down a little bit as it kind of goes through that thin Mars atmosphere, and it landed at about 200 kilometers west of one of the smaller craters, I think it's pronounced MIE, in Utopia Planitia. So the small crater inside the large crater. And they did a bunch of testing, of course, with this and all the missions to Mars. They did soil analysis. They looked at basaltic lavas. They tested for sulfates and sodium, and they found some forms of different sulfur. So sulfide of iron was also possible, and that's something that more recent rovers have found too. So it was a really fun Mars mission, and of course, they did have a biology experiment on board because people have been looking for Martians for a very long time. They didn't find any definitively, but they did have a gas chromatograph, which had a mass spectrometer and could look for chemicals that would indicate organic compounds in the Martian soil. So the results were conflicting, which of course, led to a lot of fun articles being written at the time. And a lot of people said, okay, this could be inorganic chemical reactions in the soil. It could be some sort of interesting chemistry. And some people at the time, of course, said, well, it could just be living organisms too. So, so how about that? But it was a great time in Mars history, a great time in landers. The Viking program, of course, with the orbiters having discovered valleys on Mars that looked a lot like river valleys, and actually, you had streamlined islands showing that there would have been some kind of flood. So liquid used to be on the surface, even though it wasn't there now. There was different kinds of water features that you see on Earth, but on Mars and dried out. There was no water, but the water-like features were there, channels and ejecta, and all kinds of fun stuff, as well as I think, some of the very, very first actual photos of Deimos, the moon of Mars. And there's a lovely interactive color map that NASA has put up with the global topography of Mars that I definitely recommend everyone to go and click on and have fun with. So this was Viking 2, part of the Viking missions to Mars, and the Viking program overall was, identical space probes, Viking 1 and Viking 2, and it was both of them were managed, of course, by NASA. And this was the start of a lot of very ambitious things happening in, I suppose, space exploration. And interestingly, there were some new navigation systems used. So one of the things that they did was they were using gyroscopes to allow for stabilization, which wasn't done very often before this, if ever, on a large scale. So it's been a very, very interesting space history and a pretty fun launch back in September 9th, 1975.
Very cool. I tried to look up the largest impact basin for you. And what I find interesting is that the internet can't seem to agree on things.
Well, until so, I'm happy to be proven wrong. But I think it's also the fact that it's a discernible impact crater. So you can really see. I mean, this is a feature that is visible through a reasonable sized telescope. If there's no dust storms, then your skies are clear enough. It's a feature you can see on Mars from a very large distance, because it's so gigantic along the surface. And of course, Mars having the biggest volcanoes, the biggest canyon, the biggest impact crater, for this poor little small planet is just getting completely beaten up.
So yes, I did find Utopia Planitia. What I find interesting is that if you were to look it up in the Guinness World Records, it's not what you would find. They have the South Pole Aitken Basin on the moon listed as the largest impact crater.
Okay.
Which on the other list I found was listed at number 2. But
well, we can check if someone has them written down somewhere. So Utopia Planitia is listed at bigger. Around 3,300 kilometers.
Yeah, and the moon one is 2,500, so it is smaller.
Well, there we go. We'll go with the numbers then. And Utopia Planitia being such an interesting area on Mars, and one of the very earliest that we landed in. We actually had a lander looking at ice and frosts in Utopia Planitia, and now we know that this is actually an area that does have substantial water, just underground water for the most part, due to neutrino imaging and everything else. They estimate the water in the Utopia Planitia, under current estimates, is thought to be about the same amount of water in Lake Superior, which is not too far away from us here in Toronto. I don't know if is Lake Superior bigger or smaller than Lake Ontario? It's a Toronto quiz crime.
Lake Ontario is the smallest of the Great Lakes, and Lake Superior is the largest. So
Okay, so this would be more water than we have in Lake Ontario. We could tell people all about it. And of course, Utopia Planitia has not had a lot of other direct exploration. A lot of people, myself included, I just feel like, oh, it would be so cool to go there and to actually, get on the ground and properly explore it.
Mhm.
Um, just really, really hard to get there. And of course, you wouldn't want to make that 333-day trip if you were sending humans, no matter how enthusiastic they might be.
No, it's got to be a faster way to get there if you're sending people.
Yeah, even the most enthusiastic astrogeologist would probably balk at 333 days.
That's a
Um,
lot of time in a tin can.
it is a lot of time in a tin can. But if we're not sending humans, actually, I believe we can get to your next item.
Oh, sure. No humans involved in going to space in this one. Lots of humans involved in sending this one to space, though. So we are going to September 8th, 2016, and the launch of OSIRIS-REx. Regular listeners to the show have heard us talk about OSIRIS-REx a lot. Because it's so darn awesome. So in case you've been living under a rock since 2016,
Or
Osiris
2020.
or 2020, or I don't know, like 2 months ago when we talked about it.
Yeah.
Yeah. So OSIRIS-REx is an acronym. It stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith, Explorer. And basically, everything you need to know about what this spacecraft does is in its name. So the goals of the mission are to return and analyze a sample of pristine carbon-rich asteroid to study the nature, history, and distribution of its minerals and organic material, to define the global properties of a primitive carbon-rich asteroid to allow for direct comparison with existing ground-based telescopic data for all asteroids, map the global properties, chemistry, mineralogy of a primitive carbon-rich asteroid to define its geologic and dynamic history and provide context for the sample return, measure the Yarovsky effect, which is a force caused by the emission of heat from a rotating asteroid that can change its orbit over time on a potentially hazardous asteroid, and learn which asteroid properties contribute to this effect, and to document the texture, morphology, geochemistry, and spectral properties of the regolith or surface material of the sampling site. The asteroid that was selected was the asteroid Bennu. It was selected because it is one of these pristine, primitive, carbon-rich asteroids. It also happens to be in an orbit that is very similar to that of Earth, and there's a small chance that in 200 years, the Earth and Bennu will find themselves at the same place at the same time. So be good to figure out if that will actually happen by understanding its orbit as much as we can. So OSIRIS-REx started asteroid operations in August of 2018 when it captured its first image of Bennu. Its official arrival was in December of 2018, and it started surveying and mapping the asteroid. Those data were then used to identify 4 potential sample sites that were named Sandpiper, Osprey, Kingfisher, and Nightingale. Those 4 sites were observed further to narrow down the selection. The sample site Nightingale was selected, and Osprey as the backup. The sample collection rehearsal happened in April of 2020, and the sample collection occurred on October 20th of 2020. On May 10th of 2021, the spacecraft left Bennu and has been heading home ever since. And it is almost time. On September 24th, we are expecting the sample return capsule to land in Utah desert.
So exciting.
It is so exciting because the sample collection was successful. There is some amount of asteroid in the collection head, in the sample return capsule. Hopefully the thing lands nicely, and the spacecraft is not coming back to Earth. It's going to continue. It has an extended mission. Its name will change. It will become Osiris Apex, the Apex standing for Apophis Explorer, because it's going to go survey 99942 Apophis, which is an asteroid that will make a close pass to Earth in 2029. It's going to orbit Apophis for 18 months. And while it won't be able to take a sample because it doesn't have a sample return capsule anymore, it will perform a similar maneuver as it did the touch and go maneuver to disturb the surface a little bit and then study what's going on under the surface of Apophis as well. So exciting.
Very, very exciting. And of course, we've seen on social media some people who are involved with the sample return have been sending out practice pictures showing what they hope it'll look like when they get the sample out and how they're going to do it. It is hugely exciting time for everybody. I think in not just asteroid and geology, but just everywhere in astronomy. But it does seem to me like this is an awful lot of work just to get an acronym involving Rex for something that's going to go and fetch us
there are a lot of bad acronyms out there. This one's not bad. This one, I have to say, is not bad.
Yeah, I mean, if you're going to have a spacecraft that goes and fetches, I think calling it Rex is a pretty reasonable goal. And the as you say, that what it was just basically listing what it was going to do.
Yeah.
The security aspect comes more in what it's able to protect us from, I suppose.
Well, in being able to analyze the orbit of Bennu and whether or not we need to worry what's going to happen in 200 years.
Yeah, and Bennu is, for those of you who haven't heard a lot about Bennu, it is a very interesting object. If you see a picture of it, it almost looks like a big rocky diamond because it's not round in shape, and it has a very kind of low, seemingly, I don't know, low surface density, low density all over. But it looks kind of like a rocky diamond or spinning top, and it's a strange looking object, and kind of like, how did it get like this? We haven't seen a lot of other objects that look like Bennu, which makes it kind of, I wonder how typical it will be, but I'm very, very interested to see what the actual results come back as, because one of the things they said is it might actually be water rich as well, which would be cool.
Yes.
And interesting.
Yeah, so that's part of the origins part of the
Yes, exactly.
of the acronym. Like, where did the water on Earth come from? Could some of it have come from asteroids?
Yeah, and are there not so many like this because they all collided into us already?
Maybe. It's a lot looser on the surface than expected.
Yeah, well, and so was Didymos Diformos, as I recall, when they impacted that with DART, which is actually doing interesting stuff as well. So in a related mission, if you're looking at deflecting these things, make sure to read up on the DART mission.
Yeah. And And that actually became something interesting for the sample collection, because they were expecting it to be a little bit more solid and a little bit more, or a little bit less, how to put this?
Well, like,
They expected the particles on the surface to be smaller. Like they found kind of like a bunch of bigger rocks at the surface. And so they had to be really careful about the sample site selection so that they would get stuff that would fit into the sample collection head.
yeah, more gravel, less sand, I suppose.
Yeah.
Which is also very important to know if you are going to try to do more of these in the future. I suppose that gets me to my next one. Speaking of
Yes.
more missions, this is not a sample return, but it is a launch, and it does involve trying to destroy things. So, back in 1982, on the 16th of September, there was a craft called Cosmos 1408. And Cosmos 1408 was launched. It was part of the Tessalina D system. It's a spacecraft developed with the Soviet Design Office, and it had a whole bunch of different possible uses. This was a electronic signals intelligence satellite, and it was launched into low Earth orbit. Again, on that 16th of September, 1982. And this satellite in itself was fairly interesting. 1982, it was looking at electronic signals. It was launched into low Earth orbit. It replaced a previous satellite, Cosmos 1378. So there's a naming convention happening here, and operated for around 2 years before it became inactive, and it stayed in orbit. So in 1982, 83, 84, but it stayed in orbit, stayed in low Earth orbit, and it was actually destroyed in a Russian anti-satellite weapons test on 15th of November, 2021. Now, 2021 is not that long ago.
No.
This was a kind of a big deal, because when they destroyed the satellite in 2021, this satellite made a huge cloud of space debris. The space debris was in orbits between 300 to 1,100 kilometers above Earth. That's a huge range of debris. And the potential collision with debris actually caused the crew of the International Space Station to need to take shelter in their escape capsules for the first few passes of the debris cloud. So little debris in space doesn't quite work like debris on Earth. These basically become little tiny missile particles because they are flying through no friction with nothing to stop them, and they're going at very, very, very large speeds. So if they were to hit the International Space Station, they could, in theory, cause holes in the wall. They might impact sensitive systems. Of course, the space station itself is a very sensitive and contained system. So there was a real danger to, well, the space station and anything else that was in orbit, because of course this could impact it, take it out, make it crash. So this was a kind of a hugely controversial, I suppose, satellite destruction. It's not the only satellite that's ever been destroyed. Of course, the U.S. also did some satellite destruction itself, but this one is fairly new. I think, recent in people's memory, but it was actually launched on this day in 1982. And of course, its mission was, to be part of this satellite ELINT system, which is for observations and looking into sort of different kinds of radiation and stuff like that. The orbital decay since 1984 or so, so after it had been active for 2 years, was actually monitored, and they could watch it sort of decaying its orbit slowly, slowly over time. So there's actual plots showing the low Earth orbital decay over many, many, many years. Um, it didn't have any ability to be deorbited, which is what they call it when you purposely crash your spacecraft into Earth. So it's, normally what you would do if you didn't want your satellite anymore, as I suppose, a responsible person, is you'd get it out of the way of everyone else and you'd, park it in the ocean or something. So cause it to crash, but not on someone. So deorbiting is what you would try to do if you had any propulsion system. This satellite did not have propulsion. It just went up, and then its orbit slowly decayed due to small, small, small natural drag in low Earth orbit. But the anti-satellite weapons test was both a success and a huge controversy. So this is space history, but also recent history. The Outer Space Treaty, which Russia has ratified, actually bans some types of military activity in space, but not anti-satellite missiles using conventional warheads. So if you've ever wondered about space law, have a look at the Outer Space Treaty. It does cover some things, but not this, apparently. So it was a interesting time in space history and also recent history. I believe the debris cloud, as I say, it went from over 1,000 kilometers, from 300 to over 1,000 kilometers towards the end of its monitoring. So this is because as it was destroyed, it broke up into all these thousands of pieces. And they identified over 1,500 pieces of debris from this one satellite being destroyed, which is a lot. That's a lot of debris to try to track. And the fact that it then spread out to this huge region made it even harder to track. But they're hoping that it's, over time it spread out enough that the International Space Station is safe. Obviously, it didn't get hit yet, so that's good. The increasing solar activity is actually helping us. So increasing solar activity, which is one of our things we're probably going to have a chance to talk a little bit about. Solar cycle 25 is our current solar cycle, and the sun kicking up its activity is good for all kinds of things. But one of those things is actually helping a little bit, just a little bit, to knock debris out of orbit. So go sun, I suppose. I think it's one of those interesting missions that you probably heard about the satellite being destroyed. You might not have known it was Cosmos 1408.
It never ceases to amaze me. The disregard that is sometimes shown, like the space station, that thing with your own astronauts or cosmonauts on board.
Yeah.
You're going to put it in danger by blowing up this thing, so you can show those other countries that you can.
Yeah, well, the thing is, this isn't even the first time that this has happened. The US famously tried this before and had a similar problem. So we know that blowing up satellites is not a good way to take them out of orbit. Like, we know that. It causes them to fragment and spread out, and then you have 1,500 and counting fragments instead of one object to take out of. So the thing that kind of got me was like, we know so well that this was not going to work.
Oh no, it has nothing to do with showing that, oh, we got rid of this satellite. I think it has everything to do with, look what we can do with our missiles.
Yeah, but and of course, your astronauts are there too. So
that's what gets me.
Anyhow. Hopefully, this anti-satellite weapons tests are now, you know, part of the next space law treaty. There is a very
Just
good way
hoping.
to take, yeah. If you did actually just want to remove things from orbit, that's a different study that people have been looking at for a while because of all the space junk up there.
Hmm.
And active sun helps a little bit, but there's some really cool proposals for like lasers and stuff that'll help, send satellites down once they're past their lifetime. And it's just there's so many more efficient things than I mean, obviously blowing it up is the opposite of efficient, anti-efficient.
Yeah, it's just
Um,
terrible all around.
yeah, but the satellite itself was doing no one any harm.
Yeah.
It was actually fine. I mean, it's slowly coming down, so you'd have to keep an eye on it. But all right,
Yeah.
so let's see. I think we'll go ahead and take a short break here to just remind everybody that you are listening to York Universe, broadcasting live from the Allan and Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you have any chat or questions, please feel free to join in right now, live on YouTube. If you're listening to this on YouTube, you're probably already here, but you can always find us by going to yorku.ca/science/observatory and then heading on over to OPV or clicking any button that says YouTube on our site. We're also following along on Twitter at York Universe, and tonight you're listening to Julie Tomei and myself, Dr. Elena Hyde, and we're currently discussing, I suppose, satellite launches and what not to do. If you have any other ideas, topics, you can always message us and at observe@yorku.ca. And let's see, let's go on to our next section. A little bit of reminders this week. We do have a couple reminders for the show. We have a reminder and I suppose a special acknowledgement. So I'd like to go ahead and do the acknowledgement first as a little bit of a little bit of an aside, I suppose. There's been some sad news in astronomy in Toronto, especially. A very prominent astronomer and our very first astronomer in residence ever with the York University Astronomer in Residence program, Blake Nancaro has passed away, and he was our first astronomer in residence in 2022. He has been an amazing innovator and educator in astronomy, especially in Ontario. So many people in the community will know him. He kicked off our astronomer in residence program, but he's done so much more with that, with RASC and with astronomy in Ontario. Unfortunately, he has passed away, but we like to say he will remain a star in our skies. And his blog will remain, of course, featured on the Allan I. Carswell Astronomer in Residence archives. And we will also be putting a Blake's Night on the Observer's Night for anyone who's interested in signing up to observe variable stars or astrophotography. And that is actually something that any RASC member or amateur astronomer is going to be able to sign up for. Just a little side note from his official obituary, and again, it is in keeping with his wishes. His family has mentioned that September is Prostate Cancer Awareness Month. So, if desired, please consider a donation in his memory to the Canadian Cancer Society or regarding prostate cancer. So I suppose a little bit of a sad note, but huge acknowledgement to everything he's done, not just for us, of course, but also for the astronomy community and for just being an absolutely wonderful human.
Yeah, he'll definitely be missed.
So that's our. I wish I could say more. He was an amazing person, and I was absolutely privileged to know him even just for a bit. So the other reminder is a little bit less heavy. We do have one other reminder for the show today. Some of you might have seen that was just last week now. the Allan Carswell Observatory did have its official grand reopening, which marks the resumption of weekly public tours, weekly Wednesday public tours. So if you have wanted to see the newly renovated, robotic, awesome new domes observatory, please consider coming along to one of our tours that are happening every week now. The atrium tours will be on the Arboretum parking garage. The regular observatory tours will be in the observatory, and that will always be posted on your Eventbrite tickets. They're all under upcoming events on that same page I've been telling you all night, which is yorku.ca/science/observatory. So a little bit of, I suppose, a happier announcement as well.
Yeah, observatory reopening.
Yeah, and we are really looking forward to putting it all to good use. Of course, with the robotic observing, we can schedule lots of variable stars and astrophotography, and schedule our Blake's night as well as all of our other nights, and run in-person observing and mail-in cam observing and spectral analysis. So there's just so much going on and so much we can schedule. We just need the skies to clear.
Come on, skies.
Yeah, it's up to you.
Cooperate.
So if you feel like sending any clear weather our way, please send us an email. No. If you could email clear weather, I would have done it by now. But let's go ahead and move on to the news section of the evening, because we've been talking a little bit about some of the cool things the sun can do. And I think, Julie, your news item is very much related to that.
It is, and it's a launch.
And it's a launch. It's amazing.
So on September 2nd, the ISRO, the Indian Space Research Organization, launched the Aditya L1 spacecraft to the Earth-Sun L1 Lagrange point, which is located 1.5 million kilometers from Earth. And it is a great place to view the sun. So yes, India is following up its lunar mission by sending a spacecraft to the sun. So this spacecraft will reach L1 in about 3 months, and then use 7 instruments to observe the sun, its atmosphere, and the solar environment. The successful launch comes just less than 2 weeks after the ISRO made history by becoming the first to soft land a spacecraft near the lunar South Pole. The Chandrayaan-3 missions, Pragyan rover is currently in sleep mode because it's nighttime and the part of the moon where it is. And there's a chance it could wake up on September 22nd, but it's a small chance because its circuitry wasn't designed to withstand the very cold temperatures it's currently being exposed to, but time will tell. We will see. Fingers crossed on that one. But anyways, the Aditya L1 mission has the following key objectives: to study the dynamics of the sun's chromosphere and corona, to study the physics of the chromospheric and coronal heating, to study the origin and evolution of coronal mass ejections, to study the physical particle environment around the L1 Lagrange point, and to understand the drivers of space weather. There are 4 instruments on board that will study the sun and 3 that will study solar wind particles and magnetic fields, and they are as follows: the visible emission line chronograph, the VELC, the Solar Ultraviolet Imaging Telescope, SOOT, the Solar Low Energy X-ray Spectrometer, SOLEXIS, the High Energy L1 Orbiting X-ray Spectrometer, Helios, with a 1 instead of the I, the
That's the kind of password I can get behind.
Yes.
Although I hope that's not their actual password, because
somebody hacked our spacecraft. The Aditya Solar Wind Particle Experiment, aspects, the Plasma Analyzer Package for Aditya, PAPA, and the Advanced Triaxial High Resolution Digital Magnetometers. That one does not have an acronym.
I'm
tried
not
to
surprised.
Yeah, it just doesn't work. I'm really glad they didn't try to like backronym it or like force
I don't know. Could you get a Rex out of there somehow? You've got to.
No.
No.
No. Anyway, so far the spacecraft is healthy and operating nominally. So go little spacecraft, go.
Yeah, and this is just really showing off, I think, just how good ISRO is doing right now. They're making some absolutely ingenious little spacecrafts that are doing way way quality science. It's just some really good stuff. The designs are just things of beauty. So,
Yeah.
and of course, the fact that they are doing it on, a lot of cases, for a lower budget, they're
Oh yeah.
not sacrificing the science at all. And it's really, really admirable what they have accomplished. And I think I wouldn't underestimate the ISRO at all, because I just cannot wait to see what they come up with next. And of course, we're all sort of staying tuned to see what will happen as we go through with solar cycle 25. Our current solar cycle has seen so many varied predictions of whether it's going to be a strong cycle or a weak cycle. I mean, obviously, right now we're seeing an uptick in solar activity.
Mhm.
But how high will the high get? We don't know. And having something like this spacecraft in orbit, where it can really monitor the solar physics, is not just going to help, space weather, but also looking at solar magnetic storms, because people have asked what would happen if we did get another really, really big solar storm in our current modern age, when we're so dependent on satellites and phones and things like that.
Yeah, the timing is really good.
Yes, excellent timing. So perfect timing, yet another thing this mission has going for it. And measuring solar magnetic storms, those are interesting, just, in case you haven't, heard it on this show or other shows before. When the sun does emit a lot of extra high energy particles, those interact with the magnetic field of Earth, and they get funneled usually up to the poles, but they can also interact with Earth itself. So having a lot of charged particles, you can get things like discharges in power grids. Of course, we're talking about the 80s in our This Week in Space and Astronomy history, the famous Quebec power outage.
Mhm.
It's probably the most famous one in recent memory that I can think of.
Yes. Well, that was caused by a solar storm.
Yes, that I should be specific. That was known to be caused by the sun, and that's these kinds of solar storms are also good at taking out small space debris and Starlink satellites. So there's that. Every time you get a big solar flare, a few Starlink satellites come down. But
Oh, what a shame.
yeah, I mean they really do have more than enough. Um, but yes, the practical nature of the spacecraft is one really big plus point. And of course, looking into the solar atmosphere, they I think you did mention the helio. Now I'm forgetting the acronym. Helios, Hell One
Yes.
Os. Um, the Helios instrument, I believe that's the one that is going to be doing the multi-layered observing for the sun's atmosphere, which one of the things we're trying to understand with the sun is how energy is transferred from one layer of the sun to the next layer of the sun, because it's a giant ball of plasma and it's very hard to model.
Yes.
Very, very fun.
Yeah.
Well, I suppose we have about 5 minutes left. Shall we do a little tiny something different at the end?
Let's do it.
All
Just
right,
to be
so
different.
and now for something completely different. We're going to talk about exoplanets. So, well, and this is actually, it's not a direct launch, but it's related to a launch. So we're all familiar with the launch of the James Webb Space Telescope, which was put off to great fanfare and for good reason. It took a really long time and a lot of money, but boy, when it got there, James Webb Space Telescope has been amazing. It has really opened up so many areas of astronomy, not just distant galaxies, but we've seen images of our own planets in the solar system, Uranus and Neptune, both, I believe. We've seen images of, moons. We've seen images of, ancient universe artifacts and new distant, possibly most distant galaxies, and exoplanets, actually. So the last little bit of news for today is a new investigation with the James Webb Space Telescope. One of many, I might add. So there's so much JWST news out right now. We're a bit spoiled for choice. But the new one of the many new ones, K2-18b, is an exoplanet about 8.6 times as massive as Earth. And this exoplanet has been found by JWST to have evidence for carbon-bearing molecules, including methane and carbon dioxide. So the discovery here basically adds some support to recent studies of this exoplanet that could classify it as what's called a Hycean exoplanet. Now, this classification means that they hope that the exoplanet could have a hydrogen-rich atmosphere and maybe a water or ocean covered surface. So this is kind of cool. This is a insight into atmospheric properties, which is very, very, very hard to tell on other planets. So we have a great deal of trouble even telling what's happening out on Neptune in our own solar system. So looking into another solar system and actually seeing a planet and telling you anything about it is kind of amazing. So the atmospheric properties of this planet basically help us understand the system. So the planet is not going around a star like our sun. It's going around what's called a cool dwarf star, or K2 for anybody who learned the oh boy in F grade kills me. So stellar classifications in a row. The cool dwarf star, the dwarf stars tend to have more flares than our sun, but they also have very, very, very long lifetimes. And this planet is in the habitable zone of the cool dwarf star, so it would be closer in. It's more massive, and it's about 120 light years away from Earth in the constellation of Leo. So the light from that planet took 120 years to get to us as well. So these kinds of exoplanets that have sizes between Earth and Neptune, we don't really see that in our solar system. So we don't have a lot of those to look at close up because our solar system doesn't have anything there. So the lack of equivalent nearby planets, so these means that we don't really understand sub-Neptunes. So they're between Earth and Neptune. We're like, yeah, we don't really know what they're doing. But it could have water. The chemical evidence is there. It could also be some kind of, I don't know, crazy gas thing like Neptune, which also actually we should send a mission to as well. But it's really, really interesting. So I definitely recommend everyone to have a read up on K2-18b. One final little note on this interesting planet is they also provided a possible detection of a molecule called dimethyl sulfide, or DMS. On Earth, and this is not a good analogy because this is not an Earth-like planet, on Earth, this molecule is only produced by life. So take that for what you will. Very, very fun little planet. Definitely worth following up on some more. And another real, I suppose, yet another great victory for JWST.
I love it's also known as K2-18b, also known as EPIC 2019125552b.
Of course, there's an epic. So who started the EPIC survey anyways?
I don't know, but it's in all caps, so it must stand for something.
That's, if you're going to start a survey, I think calling it EPIC is a pretty good move.
Yes. You better get some results, though.
Yeah. I hadn't seen, I am not familiar with the EPIC classification, but that is pretty cool. Of course, the planet, I don't know if they've actually updated its, general information pages since this most recent discovery. But the idea that you'd have something sort of between Neptune and Earth in its habitable zone, it would be warm enough for liquid water. It would just be more massive. So would the water evaporate, or would it get so much heat that you'd have just a giant Venus? Who knows? It's a really, really interesting case. And of course, there's some lovely artists' impressions of K2-18b. So there's another art astronomy overlap if anybody wants one.
Just to tell you what EPIC stands for, it's totally a backronym. It's terrible. Ecliptic Plane Input Catalog.
It's still a good name.
It's still a good name, but yeah.
I think at that point you don't even need an acronym. You just call it EPIC and be done with it.
Yeah. I mean, you could still pronounce it EPIC and not have the I, you know what I mean? But anyways, what do I know? I'm just an astronomer.
I guess, as astronomers, I don't think we're allowed to criticize anyone's acronyms.
Fair. Absolutely fair.
On that note, it's probably time to wrap up for the show.
Yes.
Thank you, everyone. You have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. This host this evening have been Julie Tomei and myself, Dr. Elena Hyde. We are, of course, a little bit separated from astronomy.fm tonight, but we will be coming back there as soon as they are rebroadcasting, and this is still in partnership with our astronomy.fm colleagues. You can connect with us on Twitter at York Universe or York Observatory, Instagram York U Observatory, and Facebook at Allan Carswell Obs. Thanks for tuning in to York Universe, clear skies, and have a good night.
Good night.